Hello friends, in this video I am going to discuss about types of organic reactions and mechanisms. We have many types of organic reactions, but we'll discuss few of the organic reactions over here. Generally organic reactions mainly classified as addition reactions, substitution reactions and elimination reactions. In addition reaction side we have three kinds of addition reactions. One is electrophilic addition reactions, electrophilic addition reaction. Second one is nucleophilic addition reaction, and the third one is free radical addition reaction. When it comes to substitution reactions, also same. We have electrophilic substitution reaction. Secondly, we have nucleophilic substitution reaction. Nucleophilic substitution reactions. Nucleophilic substitution reactions are classified into two types. One is SN1 and SN2. And third one, we have free radical substitution reactions. Free radical substitution reactions. Okay. And elimination reaction. In elimination reactions, we have alpha elimination reactions. These are also known as 1,1 elimination reactions. Secondly, we have beta elimination reactions. Beta elimination, which are also known as 1,2. These are again classified as E1 elimination and E2 elimination. And thirdly, we have gamma elimination reactions. Gamma elimination reaction. Okay, this is also known as 1,3 elimination. We have three major reactions, organic reactions. One is addition reaction, substitution reaction and elimination reactions. These are of classification of organic reactions. And firstly, we have electrophilic addition reactions, right? Let us discuss one by one. And now let us see how the electrophilic addition reaction takes place. First, what is meant by an electrophilic addition reaction means addition reaction. It is a normal addition reaction in which electrophile is involved in rate determining step or slow step is known as electrophilic addition reaction. In non-concentrated reaction generally takes place with more than one single step, right? When more than one single step takes place, right? If that particular electrophile only involves in the particular rate determining step or the slowest step, that is going to be the electrophilic addition reaction. Okay, yeah. Generally, these are non-concentrated reaction. Non-concentrated reaction means what? It takes place with more than one single step. Intermediate is carbocation. Generally, in non-concentrated reactions, intermediate is generated. That intermediate is going to be non-concentrated reaction. Some electrophilic addition reaction takes place with the activated complex or transition state without formation of any intermediate. Some of the electrophilic addition reaction takes place. For example, we can take addition of halogens. Okay, first formation of halonium cyclic halonium ion formation takes place and followed by the addition of halide ion, right? What happens? Addition product of halogen addition product takes place. Generally, alkenes, alkadines and alkynes undergo electrophilic addition reactions. These are double bond with two double bonds, here triple bonds, right? Substrate with electron releasing group is more reactive in electrophilic addition reaction. Why is that? Means if you take electrophile, right? The incoming electrophile is electron deficient, right? It is going to attack an alkene. If alkene has more electron density over here, right? When it has more electron density over here, the addition readily takes place. Okay, since electrophile is electron deficient, substrate is electron efficient, right? That's what happens. Addition readily takes place with the substrate when it has electron releasing groups over there. And then if carbocation stability increases, rate of the reaction increases. One thing we have already discussed earlier. What is that? If stability of the intermediate increases, right? They are kinetically favorable reactions. If formation of product takes place through the stable intermediate, that is going to be major one. If stability of the carbocation increases, rate of the reaction also increases. Kinetics explains the rate of the reactions, right? Then in this reactions, right, carbocation rearrangement takes place. How carbocation rearrangement takes place? Now let us assume that carbocation has generated over here. What is this carbocation? It is a secondary one. Let us see the adjacent positions here. Here primary carbon, here tertiary carbon. Generally, carbocations, tertiary carbocation is more stable than that of secondary one, right? Here what happens? There is a possibility of getting more stable carbocation. That's what happens. If we have hydrogen, hydrogen shift takes place. When hydrogen shift takes place, what happens? Here we'll get the carbocation. This carbocation is tertiary one. Comparatively with the secondary one, tertiary one is more stable. That's what rearrangement takes place. Sometimes hydride shift takes place, sometimes methyl shift also may takes place over there. Here ring expansion also takes place. How ring expansion takes place? Now let us assume one particular example here. Now let us assume carbocation has generated at this particular position. Now generally 3-member ring and 4-member rings are likely to be unstable because of bond angle deviation. What happens is that by ring expansion, what happens? 5-member ring formation takes place. 5-member ring formation takes place. Any one of these positions, carbocation is generated, right? What happens is that comparatively with this particular ring, the second 5-member ring is more stable. That is why ring expansion also takes place during the reaction. Generally, aromatic double bonds are not involved in the electrophilic addition reaction. If you take a benzene ring, right, generally, okay, we have double bonds inside the benzene, right? These double bonds are not involved in electrophilic addition reaction. These are all about general data about the electrophilic addition reactions. And now let us see how a general electrophilic addition reaction takes place with an alkene. Now let us take an alkene over there. Let us take an alkene over there. This is the alkene, and let us add a reagent over there. Okay, let us assuming this part is positive part of the reagent, this part is the negative part of the reagent, and these two would be added to the alkene over there. What we'll get? We'll get the products of these kinds. Nucleophile, or this is a kind of trans addition, right? Sometimes we'll be also getting cis addition. What is that? How the cis addition is going to be? Both the negative part and the positive parts will be added to the same side. This is a cis addition. Any one of these kind of addition may takes place during the reaction. Now let us see how the reaction mechanism takes place generally. Okay, let us take a particular alkene over there. Let us take a mechanism here. Mechanism. First, the reaction, what happens? Generation of electrophile takes place. E plus Nu minus. This is the electrophile for the reaction. And let us take an alkene over here. This is an alkene, right? Now, when this alkene attacks the electrophile over there, electrophile means what? We know electron loving species are electron deficient, or which are in need of electrons, right? Means if this is an electron deficient species, means this should be electron rich, right? Then only addition will take place. Alkene attacks the electrophile over there. After attacking, what happens? Electrophile. This is what we are getting, right? Now, one thing we have to remember, right? Addition of electrophile is taking place, right? We are discussing about electrophilic addition reaction, right? This is taking place in rate determining step, or we can also call it as slowest step, slow step. Okay, that's why this reaction is known as electrophilic addition reaction. The second step, what we have the negative part of the reagent, right? This negative part of the reagent will be added over there. When it added, what happens? We'll get this kind of product. Okay, this is the product. Okay, now what is this one? This is the slowest step. In the slowest step, electrophile is involved. And second thing is that we have an intermediate, that is carbocation. This is intermediate, and this is the final product. Okay, now let us take some other exceptions, right? In the addition reaction, we have seen that some of the reaction takes place, like some of the reactions are non-concerted, takes place with intermediate, some reaction takes place with only transition state, right? How this one takes place, let us see an exception. Let us take an alkene. What is happening now? We'll add the same reagents over there. What happens? It forms a kind of activated complex, or we can also call it as transition state. Okay. It is forming a kind of transition state here. Okay. Means there is no formation of carbocations or rearrangement takes place with these kind of mechanism. Transition state are activated complex. When activated complex or transition state formation takes place, like, right, there is no rearrangement of carbocations. Carbocation itself is not generated, right? That's what we are calling it as. There is no rearrangement of carbocations over there. Okay. And in the final step, what happens? Formation of a bond takes place between electrophile and the nucleophile. And then what happens? That is what we'll be getting. Most of the reaction, right, in addition reaction, right, with transition state, most of the times we'll be getting trans addition product. We'll discuss all these things in detail in the upcoming videos.